So I updated the game. We've now got camera rotation, which feels a little tricky to use sometimes, but it's useful for when I'm reading or writing binary somewhere. You can also rotate anything you copy, which is really useful. I've wanted that for a long time, like since copying and pasting was a thing. And also I figured out what caused phase crabs to happen, like the actual long phase crabs, and I brought it back. And now we have phase crabs that can travel multiple blocks. So the rest of this video is going to be a tutorial, basically how to do some of the stuff that I've done, like make computers, obviously not fully in depth, just some of the components of them, and how to do the same thing with phase crabs and why it's better. So we're back in crabs, and there are just a few things I want to clear up. First of all, when the crabs move, that is called a tick. So every time the crabs move, that's now, and now, that's all a tick. So this guy here is a 4-tick cloner, which means every 4 ticks a crab comes out. To work out what kind of cloner you have, you look at the space between, add 1, and that's what tick this cloner is. So the 4-tick cloner is the most common one, but you can get other ones like the 2-tick cloner and the 6-tick cloner, so I will just make them now. So you can see that when you put them all beside each other, there's a lot more space between the longer one, a bit less, and then much less between this. And you can see the same pattern holds up. So you look at, there's only 1 space between. So you add 1, it must be a 2-tick cloner. This is 3 spaces. You add 1, it must be a 4-tick cloner. This is 5 spaces. So you add 1, it must be a 6-tick cloner. I only ever use the middle one because it has a lot more space between the crabs, but it's not an excessive amount of space. It's just enough to let some other crabs through if I needed to, like so. Also with cloners, another really important thing is tempo. So I'm going to put 4 cloners here. So these are 4-tick cloners. That's why I'm putting 4 of them, but they're all going to be at a different, you would call it a different tempo. So that should be all of them in a different tempo. Yep. Okay. So what you see is 4 crabs coming out of each one, but they're all off by 1 from each other. And this covers every tempo that a 4-tick cloner can produce. And so what you, I don't usually label it like 1, 2, 3, 4, but I just know when they're a different tempo. So you would say that this crab line here is in a different tempo to this crab line here. So because they're in a different tempo, they can never collide. So this makes more sense usually for crab cloners that are in a different axis. So you might have a vertical one and a horizontal one, and you have to work out what tempo they're in, which is basically what spot they're in inside of their cloner. So in the most basic case, when they come out at the same spot, they just have to be in the same spot in their own cloner. So you can see that if I let this run, if I go like that, they come out at the same spot at the same time and they annihilate each other. So these are in sync, they're in the same tempo. Now, if I was to move this one far away, which usually is what happens, usually you will not get ones that are lined up like that. It just doesn't happen so easily. Now, they are in the same spot in their relative cloners, but when they come out, they won't necessarily line up. So you can see that this one is actually a little bit before this one, and so they just will not be able to link up. So in this specific case, I'm pretty sure if I put it here, then it will sync them back up. So I'll just try that. Nope, it's too off. So let me put it there and now it will sync up. So you can see that they sync back up again, even though they're in different spots. So you sort of just have to use trial and error, just figure out what tempo it has to be in for them to sync up. And that's probably the hardest thing in this whole game, just syncing things up, getting the right tempo, which is why I have syncers. So often in situations like this, you will have a crab cloner, but without an actual cloner block, it will just be 2 regular blocks next to each other. And what that is a crab syncer. I just usually call it a syncer. It just syncs up the crabs that are nearby. And it's something for you to look at. It doesn't change anything in the game. It's just for you to know that, for example, if I got rid of that, and I no longer knew what the tempo was supposed to be, then instead of having to work it out through trial and error, I just know that it has to be here. So then I can turn it back on and it works perfectly fine. So this is really good for situations where I'm trying to set some stuff myself, like set the lines of code that I want this computer to run. So for example, over here, I'll just turn so you can see it. So what I have here is actually 4 syncers in a row to tell me exactly what position these 4 cloners are supposed to be in. So if I want to put a bit into exactly this spot, I know that it can't be here, can't be here, can't be anywhere else. It has to be there. And say I want another one in this one here, so I'll just press enter to line it up so I know exactly where it is. Then I can put it there, and you can see that they will sync up. Now, when the crabs come through here to collide with this, you can just trust me, they do sync up. I've tested this. But that's how you know you have these syncers, because otherwise it would be the hardest thing ever to try and work out where all these crabs are meant to be. But I have the syncer, so I know. This right here is called a crab bin or a crab destroyer. I usually call it a crab bin. You'll sometimes see them like this as well. It doesn't really matter, as long as it's some stretch of purple with at least one piece of purple to allow crabs to rotate, and then blue on either side to actually keep them held in. That is still a crab bin. So you can see that it just deletes the crabs, and that other guy I sent up there just came back. And it really doesn't matter how big this is. Like, I could put it there, I could make this a lot smaller, and you usually will see ones that are just that big. But if you do make it any smaller than that, it will come out the other side because of phasing, which is something I will get to in a minute. This is a repeater, and now repeaters also have ticks just like cloners, except the tick for a repeater is how long it takes to activate. So just like in Minecraft, when you have a repeater that can take a certain number of ticks, it's a very similar concept, except that in crabs, you can have both 0 tick repeaters and negative tick repeaters. Obviously, negative tick doesn't exist in Minecraft because it doesn't make sense. Now, when this top crab goes through the repeater, it loses some speed. You could say that it gets paused for a few ticks. Now, this one, I believe, is a 4 tick repeater that I've just made. So it loses a tick right there when it has to rotate. Now, it loses another one when it goes down. It loses another one to rotate again. Now, it goes across twice, doesn't lose anything. Then it loses one again, goes up, loses one again, and loses one again. So that is, I think, a 6 tick repeater actually, which means that it is this much slower, which is 6 blocks. So obviously it is better to have a 0 tick repeater if you can, but they're a lot harder to make, but it makes use of phase crabs, which I will now get to. So first of all, the easiest way to make a phase crab is by putting blocks after a cloner. So super simple. Have the cloner here, spawn crabs directly into a block, and they will become phase crabs. So you can see right now it just spawned a crab, and you might just be able to see the pixels of it behind that block. Now, it's going to stay in blocks for its entire lifetime until it exits the block. So you can see that it travels across. I know it's hard to see, but I promise it's at the end right there. And now it comes out. So this is no longer a phase crab, yet the ones inside are still phase crabs. So that's what you call them. That's the correct terminology for this. A phase crab is a crab that is currently inside of a block. Now, one other way to make phase crabs is through rotation. So not only through cloning, but you can actually rotate crabs into phase crabs. So what I've made here is all you need to make a phase crab without a cloner. So if I grab a crab and put him right here, what's going to happen is he's going to go to the right, he's going to rotate, but it normally would be to the right, except because there's a block here, it turns it into a left rotation. And because it has already become a left rotation, it will go through this block no matter what. So I'll send him through. He rotates to the right. So he's actually facing down right now. He sees this block and he looks at that and says, okay, I have to bounce off of that now. So he bounces off and he goes into this block. Now, just to show you that it works, I'll put a few blocks there, and you can see he does go inside the block, and after a few ticks, he comes out. So that is a way to make a phase crab. And obviously when it comes out, it can react to blocks again, just like normal. So just to show what you could do with that, you could make a loop like this. Maybe the crab goes around in a circle like that, and for about half the time, it's a phase crab. Now, one useful feature of phase crabs is that they can allow you to create intersections. So normally crabs would collide if they enter each other, just like this. They collide and they annihilate each other. But if you replace this with a phase crab intersection, let's say something like this, they will actually pass through each other. And you can see that while they are phase crabs, they cannot collide with anything, which means they cannot be annihilated. And I am sending 2 crab streams directly through each other. You can see that as they come out, they are completely at the same spot in their relative streams, and therefore they should have collided, but they didn't. Before I explain the next thing, first of all, crab speed is what you call the maximum speed a crab can travel at. So crab speed is just 1 block every tick, so 1 block per tick. Now what you can do with phase crabs is allow crabs to travel at just above 1.3 blocks per tick. So it's a third faster than usual, but it's still more than 1 block per tick. So I'm going to put a crab here. I'm going to let this one start this chain that I've made. And now these two crabs are lined up with each other. But watch what happens when it gets to this side. You can see it was a phase crab just for 1 tick that allowed it to get through this rotator. So now it's going to hit the cloner, clone into the next one, so the chain continues, and this one will get sent back to here and it will just get disposed of. It'll get sent away. Nothing really happens to it. I might just put something up here to stop it from meddling with all of that. But it just gets sent away. And what happens is every time it hits a cloner, it advances by 1 block. By the end, you can see that this one is actually 2 blocks ahead of this crab, which means it traveled faster than crab speed. So this is probably one of the coolest things I've ever discovered in crabs. But that's pretty much all there is to phase crabs, and all of those features come together to make a lot of things possible that should not normally be possible. So if you're still watching the video until now, this is my next 4-bit computer, the second version. It's a lot smaller than the first one. I'll show a comparison in a sec. Basically, the top part here is the address decoder, which reads the current line number that you're up to, and then goes down here into the program memory and reads whatever line it wants to get, and sends that across this is the instruction bus, takes the instruction of that line, sends it to the left side, and this is the, I'd say like argument or operand bus. So it takes the argument of that instruction and sends it to the left as well. And down here is like just some designs I'm making for some kind of repeater that actually, I want the lowest tick repeater possible that can actually take it across to the left. And I've been having some trouble doing that. Right now, it's looking like it's going to have to be a 6-tick repeater, which is like the worst that you can get. I was trying to do a 4-tick repeater, but it was working for a while, but then something in here made it so that I can't put it in that spot, and so I don't think it's going to work out. But yeah, I might do some videos that just like show the development of this computer. Like I might do a video explaining how I solve this repeater thing, if I can solve it. And maybe like whatever the next parts are, I'll just make videos about them, but we'll see. Okay, for comparison, the same parts that I just pointed out are this. So from here, this is the top one, and then this, okay? So the top here is the address decoder, which decodes the line number that you're up to. And the middle part here is the program memory. So this is the instruction, and this is the argument. Now the same thing that I just made is that. It fits into such a small space. This is the whole thing. So yeah, I'll keep you guys updated on what's happening with this new computer. And yeah, I'll show you if it does anything cool. See you on the next one.